Hello, in this lecture we will find the area of the green triangle. In the drawing we have triangle ABC that is an equilateral triangle, and inside triangle ABC we have the green triangle that is a right triangle because angle FDE of the green triangle equals to 90 degrees. For that reason, the green triangle is a right triangle. And we also know that AF equals to BF, BD equals to 2 units, and DC equals to 4 units. And we want to find out the area of the green triangle. Okay, first of all, the angles of any equilateral triangle equals to 60 degrees. So angle BAC equals to 60 degrees. And also angle ABC equals to 60 degrees. And angle BCA equals to 60 degrees. Okay, and we also know that all the sides of an equilateral triangle are equal to each other. That is to say, AB equals to BC equals to AC. Okay, AB equals to BC equals to AC. Okay, in any equilateral triangle, all the sides are equal to each other. For that reason, AB equals to BC equals to AC in the equilateral triangle ABC. Okay, but we also know that BD equals to 2 units and DC equals to 4 units, and BC equals to BD plus DC. So actually BC equals to BD, that is 2 units, from plus DC, that is 4 units. Okay, BC equals to BD plus DC. BD equals to 2 units and DC equals to 4 units. So actually side BC of the equilateral triangle equals to 2 plus 4 equals to 6 units. Okay, so you can write here that AB equals to BC equals to AC equals to 6 units. Okay, and we also know that AF equals to BF. So we will define AF as X, and if AF equals to X, then BF also will be equal to X because AF equals to BF. So what is the size of AB? AB equals to AF plus BF. That is to say, AB equals to AF, that is X, plus BF, that is also X. So actually AB equals to X plus X, that is 2X. So AB equals to 2X for one side, but okay, AB equals to 2X from one side, but from the other side we know that also that AB equals to 6. So we can add here that AB also equals to 6 units. So we actually got this equality that states that 2x equals to 6, and if we divide this equality by 3, we will get that x equals to 3 units. Okay, so x is AF and it equals to 3 units, and BF also equals to X, and X equals to 3 units, so actually BF equals to 3 units. Okay, and in the next step we will define side AFD of the green triangle as A. That is to say, FD equals to A, and we will define side DE of the green triangle as B. And we should also know that the green triangle is a right triangle because angle FDE of the green triangle equals to 90 degrees. So actually the area of the green triangle will be equal to the base of the triangle, that is B, times the height of the triangle, that is A, over 2. So A times B over 2 is the area of the green triangle. So the only thing that we need to do is to find out the value of A and the value of B, and then we will know the area of the green triangle, that is actually A times B over 2. Okay, so in order to find out the value of A, we will use the law of cosines. So what is the law of cosines? The law of cosines applies to any triangle. So we can write here that in any triangle we can use the law of cosines because it is true for any triangle. So if we have a triangle that this side of the red triangle equals to A, this side of the red triangle equals to B, and this side of the red triangle equals to C, and this angle equals to theta, then according to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB times cosinus theta. Okay? Again, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. And it is true for any triangle. So we can implement the law of cosines in any triangle. So we actually can implement the law of cosines in the small triangle BFD, this triangle. So in triangle BFD, FD square, according to the law of cosines, equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. So, according to the law of cosines, in the small triangle BFD or FBD, FT square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, again, FD square equals to BF square plus BD square times BF times BD times cosinus 60 degrees. Or FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. But what is the value of FD? We defined FD as A, so FD square will be equal to A square, and FD square equals to BF square. What is the value of BF? BF equals to 3 units, so BF square is 3 square, 3 square is 9, plus BD square. The value of BD is 2, so BD square is 2 square. 2 square is 4, minus 2 times BF is 3, times BD is 2, times cosinus 60 degrees. Cosinus 60 degrees is 1 over 2. So in total we got that A square equals to 9 plus 4 minus 2 times 3 times 2 over 2. Here we have 2 in the numerator and 2 in the denominator, so we can cancel 2. And what is left after we cancel 2 here? We will have that this following expression, that A square equals to 9 plus 4 is 13 minus 2 times 3 is 6. So what is left is A square equals to 13 minus 6. 13 minus 6 is 7, so we got that A square equals to 7. Okay, A square equals to 7, so we will take a root out of this equality, and we will get that A equals to root of 7 units. Okay, so we found out the value of A. A equals to the root of 7 units. And in the next step, we will define angle BFD as theta, angle BDF will be defined as alpha, angle EDC will be defined as gamma, and angle DEC will be defined as beta. Okay, and we will use the law of sines in order to find out the value of sinus theta. What is the law of sines? Actually, the law of sines, first of all, apply for any triangle. So you can write here that the law of sines in any triangle, you can use the law of sines in any triangle. If we have a triangle in the red triangle, if this side is A, this side of the red triangle is B, this angle between A and B is angle theta, and no, this side of the triangle is C, this angle is gamma, this angle is alpha, and this angle is beta. Then, according to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, and it applies to any triangle. Again, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, so we actually can implement the law of sines in the small triangle FBD. So in the small triangle FBD, we will implement the law of sines. According to the law of sines in the small triangle FBD, BD over sinus theta equals to FD over sinus 60 degrees. Again, BD over sinus theta equals to FD over sinus 60 degrees. So that is actually the implementation of the law of sines in the small triangle FBD. BD over sinus theta equals to FD over sinus 60 degrees. Okay, but BD equals to 2 units, and sinus theta is sinus theta. We actually want to find out the value of sinus theta according to this equation. So 2 over sinus theta equals to FD. We have already found out that the value of FD, that is A, equals to the root of 7 units. So FD is the root of 7 units over sinus 60 degrees. The value of sinus 60 degrees is actually equals to root 3 over 2. Okay, so in total we got that 2 over sinus theta equals to the root of 7 over root 3 over 2. Okay, so we will move 2 to the numerator and root 3 to the denominator of this expression. So we will get that 2 over sinus theta equals to 2 times root 7 over root 3. Okay, so we got that 2 over sinus theta equals to 2 times root 7 over root 3. Here we have 2 in the numerator of this side of the equation, and we have 2 on the other side of the on the numerator of the other side of the equation. So we can cancel 2, and what left after we cancel 2 is actually 1 over sinus theta equals to root of 7 over root 3. Okay, after we cancel 2, what is left is 1 over sinus theta equals to root 7 over root 3. Here we will multiply this equality by sinus theta, and we will get that 1 equals to sinus theta times root 7 over root 3. Okay, here we will multiply this equality by root 3, and we will get that root 3 equals to root 7 times sinus theta. Okay, here we will divide this equality by root 7 in order to get the value of sinus theta, and we will get that the value of sinus theta equals to the root of 3 over root 7. Okay, so we found out the value of sinus theta. In the next step, we will find the value of cosinus theta by using a trigonometric identity. We have the following trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. So that is our trigonometric identity. Sinus theta squared plus cosinus theta squared equals to 1. From this trigonometric identity we will subtract sinus theta squared and we will get that cosinus theta squared equals to 1 minus sinus theta squared. Okay, in the next step we will take a root out of this equality and we will get that cosinus theta equals to the root of 1 minus sinus theta squared. Yes. So we got actually the value of cosinus theta, and we have already calculated the value of sinus theta. We know that sinus theta equals to the root of 3 over root 7. Sinus theta equals to the root of 3 over root 7. So if sinus theta equals to the root of 3 over root 7, then sinus theta squared will be equal to 3 over 7. So sinus theta squared equals to 3 over 7. So we actually can substitute sinus theta squared in this identity by 3 over 7 because sinus theta squared equals to 3 over 7. Okay, so we will get that cosinus theta equals to the root of 1 minus, instead of sinus theta squared, we will write 3 over 7 because sinus theta squared equals to 3 over 7. So we got that cosinus theta equals to the root of 1 minus 3/7. 1 minus 3 over 7 equals to 4 over 7. So I write it down that cosinus theta equals to the root of 4 over 7, but we know that the root of 4 is 2, so I write it down. Cosinus theta equals to 2 over root 7. Okay? And we have already found that the value of sinus theta is root 3 over root 7. So we found out the values of cosinus theta and sinus theta. Okay? So In the next step, we will create 4 equations. Our first equation states that in triangle FBD, this small triangle FBD, the sum of its angles equal to 180 degrees. So our first equation will be 60 degrees plus alpha plus theta equals to 180 degrees. Okay, again, our first equation states that the sum of the angles in the small triangle FBD equals to 180 degrees. Our second equation states that in the small triangle DEC, the sum of its angles equals to 180 degrees. That is to say, 60 degrees plus gamma plus beta equals to 180 degrees. Again, our second equation states that the sum of the angles in the small triangle DEC equals to 180 degrees. Okay, so in the next step, we will add equation number 1 and equation number 2 together, or we will add equation number 1 to equation number 2, and we will get equation number 3. So equation number 3 is the addition of equation number 1 with equation number 2. Okay, so 60 degrees plus 60 degrees is 120 degrees, plus alpha plus theta, plus gamma plus beta, and in the other side of the equations we have 180 degrees plus 180 degrees equals to 360 degrees. Okay, again, we created equation number 3 by adding equation number 1 to equation number 2. Okay, and now we will create equation number 4 that states that the sum of the angles in the upper side of a straight line equals to 180 degrees. So if we look at point D in relation to the straight line BC, what are the angles that in the upper side of line BC? They are actually alpha plus 90 degrees plus gamma. So the sum of these angles equals to 180 degrees. Okay? So the fourth equation states that the sum of the angles in the upper side of any straight line equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, again, equation number 3 states that the sum of the angles in the upper side of a straight line equals to 180 degrees. Okay, here we can subtract 90 degrees from equation number 4, and we will get that alpha plus gamma equals to 90 degrees. So according to equation number 4, alpha plus gamma equals to 90 degrees. But actually, in equation number 3, first of all, we will subtract 120 degrees from equation number 3, and we will get that alpha plus theta plus gamma plus beta equals to 240 degrees. 600 degrees minus 120 degrees equals to 240 degrees. Okay? But as you can see, in equation number 3, we have alpha plus theta, exactly like equation number 4. So actually we can substitute alpha plus theta from equation number 3 by 90 degrees because of the fact that alpha plus theta equals to 90 degrees. Okay, so we will do it now. We will get that 90 degrees plus theta plus beta equals to 240 degrees. Here we can substitute 90 degrees from equation number 3, and we will get that theta plus beta equals to 150 degrees. Okay, equation number 3 states that theta plus beta equals to 150 degrees. Now we will subtract theta from equation number 3, and we will get that beta equals to 150 degrees minus theta. Okay, so according to equation number 3, beta equals to 150 degrees minus theta. But if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. Very simple. Okay, so we can write that from this equality we can deduce that sinus beta equals to sinus 150 degrees minus theta. Okay, sinus beta equals to sinus 150 degrees minus theta. So in order to calculate the value of sinus 150 degrees minus theta, we will use second trigonometric identity of sinus alpha minus beta. The value of sinus alpha minus beta equals to sinus alpha times cosinus beta minus sinus beta times cosinus alpha. Okay, actually this is the second trigonometric identity that we will use in order to find out the value of sinus 150 degrees minus theta when alpha equals to 150 degrees and beta equals to theta. So according to the second identity, sinus 150 degrees minus theta equals to sinus 150 degrees times cosinus theta minus sinus theta times cosinus 150 degrees. Okay, again we implemented the second identity of sinus alpha minus beta in order to calculate the value of sinus 150 degrees minus theta when alpha equals to 150 degrees and beta equals to theta. So what is the value of sinus 150 degrees? The value of sinus 150 degrees is 1 over 2 times cosinus theta. We have already found out the value of cosinus theta. Cosinus theta equals to 2 over root 7. So it is minus sinus theta. We also found out the value of sinus theta. Actually, sinus theta equals to the root of 3 over root 7. Times cosinus 150 degrees, and the value of cosinus 150 degrees equals to minus root 3 over 2. So we got that 1 over 2 1 over 2 times 2 over root 7 minus root 3 over root 7 times minus root 3 over 2. It is actually equals to sinus 150 degrees minus theta. This is actually equals to sinus beta. First of all, we have 2 in the numerator and 2 in the denominator of this expression, so we can cancel 2. And we have here minus times minus, minus times minus is plus, and root 3 over root 3 is 3, so we can write down all the new values. After we cancel 2, what is left is 1 over root 7, and minus times minus is plus. Root of 3 over root 3 is 3. So we have 3 over 2 times 1 over root 7. Okay, so we got that 1 over root 7 plus 3 over 2 times 1 over root 7, that is the value of sinus 150 degrees minus theta, that equals to sinus beta. In the next step, we will take 1 over root 7, we will take out 1 over root 7 as a common factor of this expression. Okay, we will take out 1 over root 7 as a common factor of this expression. And we will get that 1 over root 7, that is the common factor that we took out. And inside the brackets we will have 1 plus 3 over 2. Okay? So 1 plus 3 over 2 is 2.5, and 2.5 equals to 5 over 2. So in total we will get that all this expression starts from sinus beta. So all this calculation were the values of sinus theta. So we can write down that the value of sinus beta equals to 1 over root 7 times 5 over 2. Okay, actually we found out the value of sinus beta. Sinus beta equals to 1 over root 7 times 5 over 2. Okay, so after we found out the value of sinus beta, we actually can use the law of sines in order to find out the value of B. According to the law of sines, in the small triangle DEC, DC over sinus beta equals to DE over sinus 60 degrees. Again, in the small triangle DEC, this triangle, DE over sinus 60 degrees equals to DC over sinus beta. Okay, or DC over sinus beta equals to DE over sinus 60 degrees. What is the value of DC? DC equals to 4 units. Okay, DC equals to 4 units. And we have already found out the value of sinus beta. Sinus beta equals to this expression, 5 over root 7 times 2. So we can write the value of sinus beta, that equals to 5 over 2 times root 7, all equals to DE. DE is B according to our definition, over root 60 units. Over root of sinus 60 degrees. So sinus 60 degrees equals to root 3 over 2. So actually in total we got that 4 over 5 over 2 times root 7 equals to b over root 3 over 2. Here we can move 2 to the numerator, root 3 to the denominator, and here on the other side of the equation we can move 2 times root 7 to the numerator and 5 to the denominator. It is very simple arithmetic, and we will get that 2 times root 7 times 4 over 5 equals to 2b over root 3. Okay, after doing the simple arithmetic, we got the 2 times root 7 times 4 over 5 equals to 2 times b over root 3. We have 2 in the numerator of this side of the equation and 2 in the numerator of the other side of the equation, so we can cancel 2. So what left after we cancel 2? Root 7 times 4 over 5 equals to b over root 3. So here we can simply multiply this equality by root 3 in order to get the value of b. So the value of b will be equal to root 7 times root 3 times 4 over 5. Okay, so we found out the value of b, and we already found out that the value of a is root 7 units. So after we know the values of a and b, we can find the value, the area of the green triangle, because what is the area of the green triangle, green right triangle FDE? The area of the green right triangle FDE equals to the base of the triangle, that is B, times the height to the base, that is A, over 2. Okay, you can see that the height A creates 90 degrees with the base B, because this angle is 90 degrees, so the area of the green triangle equals to B times A, or A times B, over 2. And we already know the value of B and the value of A, so we simply will substitute B by the value of B, and we will substitute A by the value of A, and we will get the area of the green triangle FDE. Okay, so the area of the green triangle FDE equals to A equals to root 7 times the value of B, that is root 7 times root 3 times 4 over 5, all divided by 2. Okay, we got that the area of the green triangle FDE equals to root 7 times root 7 times root 3 times 4 over 2. Root 7 times root 7 is 7, and 4 over 2 is 2, so I write it down. So the area of the green triangle FDE equals to 7 times 2 times root 3 over 5. Okay, we got that the area of the green triangle FDE is 7 times 2 times root 3 over 5. 7 times 2 is 14, so we will write it down. So the area of the green triangle FDE equals to 14 times root 3 over 5 square units. So we found out the area of the green triangle FDE, this green triangle. We found that the value, the area of the green triangle FDE equals to 14 times root 3 over 5 square units. Or in terms of numbers, the area of the green triangle FDE equals to 4.85 square units. Okay, so the area of the green triangle FDE equals to 4.85 square units. Again, the area of this green triangle FDE equals to 4.85 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green triangle FDE. The green triangle is located inside the big triangle ABC, that is an equilateral triangle. In any equilateral triangle, all the angles equals to 60 degrees. So this angle is 60 degrees. Angle ABC is 60. Angle ABC is 60 degrees, and angle BCA also equals to 60 degrees. And we know that in any equilateral triangle, all the sides are equal to each other. That is to say, AB equals to BC equals to AC. Okay, and we also know that AF equals to BF and BD equals to 2 units and DC equals to 4 units. And we want to find out the area of the green triangle FDE, and we know that the green triangle is also a right triangle because of the fact that angle FDE is a right angle. It equals to 90 degrees. Therefore, triangle FDE, the green triangle FDE is a right triangle. Okay, so first of all, we know that AF equals to BF. Okay, so we defined AF as X, and if AF equals to X and AF equals to BF, then BF also equals to X. And we know that AB equals to AF plus BF. So actually, if AF equals to X and BF equals to X, then AB that equals to AF plus BF will be equal to X plus X. That is to say, AB equals to 2x from one side, but from the other side, we know that BC equals to BD plus DC. That is to say, BC equals to BD, that is 2 units, and DC, that is 4 units. That is to say, BC equals to B, that is 2, plus DC, that is 4, or BC equals to 6 units, and it is also the value of AB, because all the sides in an equilateral triangle are equal to each other. So from one side we know that AB equals to 2x, and from the other side we know that AB also equals to 6. So from this equality we can derive this equality that 2x equals to 6, and if 2x equals to 6 we can divide this equality by 2, and we will get that x or x equals to 3 units. So AF equals to x equals to 3 units, and BF also equals to x equals to 3 units. And in the next step we defined FD, that is one side, it is actually the perpendicular of the right grade triangle. FD, we defined it as A, and we defined the other perpendicular of the right triangle FDE as B. And then we actually used the law of cosines in order to find out the value of FD, that is actually A. According to the law of cosines, in any triangle, if this side is A, if this side is B, and if this side of the right triangle is C, C square equals to A square plus B square minus 2 times A times B times cosinus theta. Again, it is true for any triangle. So we actually implemented the law of cosines in the small triangle FBD. In the small triangle FBD, according to the law of cosines, FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, again, in the small triangle FBD, FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, but FD equals to A. According to our definition, FD equals to A, and FB equals to 3 units, so FD square is 9, and BD equals to 2 units, so BD square is 4, and 2 times BF times BD is 2 times 3 times 2, and cosinus 60 degrees is 1 over 2. So we did these calculations, and we found out that the value of A is root of 7 units. Okay, the value of A is root of 7 units, and in order to find out then we defined angle BFD as theta, angle BDF as alpha, angle EDC as gamma, and angle DEC as beta. And in order to find out the value of sinus theta, we implemented the law of sines in the small triangle FBD. What is the law of sines? The law of sines, first of all, applies to any triangle. In any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay? So we implemented the law of sines, the small triangle FBD. According to the law of sines, BD over sinus theta equals to FD over sinus 60 degrees. Okay? BD over sinus theta equals to FD over sinus 60 degrees in triangle FBD according to the law of sines. We know that BD equals to 2 units and sinus theta is sinus theta. FD equals to the root of 7 units and the value of sinus 60 degrees is root 3 over 2. So we solved this simple equation and we found out that the value of sinus theta equals to the root of 3 over root 7. In the next step, we found the value of cosinus theta by the trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. Okay, if we subtract sinus theta squared from this trigonometric identity, we will get that cosinus theta squared equals to 1 over sinus theta squared. We took out a root out of this, took out a root out of this equality, and we got that the value of cosinus theta is the root of 1 minus sinus theta squared. Okay? And we know that the value of sinus theta is root 3 over root 7, so if the value of sinus theta is root 3 over root 7, then the value of sinus theta squared will be equal to 3 over 7. So we can substitute sinus theta squared by 3 over 7 because sinus theta squared equals to 3 over 7. Okay, and we got that cosinus theta equals to 1 minus 3 over 7, and we got that the value of cosinus theta is 2 over root 7, and we have already found out that the value of sinus theta equals to root 3 over root 7. Okay, then we created 4 equations. The first equation is related to the small triangle FBD. The first equation states that the sum of the angles in triangle FBD equals to 180 degrees. That was our first equation. The second equation states that the sum of the angles in triangle DEC equals to 180 degrees. That was our second equation, and we added equation number 1 to equation number 2, and we got equation number 3. Then we created also equation number 4 that states that the sum of the angles in the upper side of any straight line equals to 180 degrees. So in the straight line BC, the sum of the angles in the upper side at point D is actually alpha plus 90 degrees plus gamma, that equals to 180 degrees. Okay, alpha plus 90 degrees plus gamma equals to 180 degrees. That was our fourth equation. From the fourth equation, we got that alpha plus gamma equals to 90 degrees. and then we substituted alpha plus gamma by 90 degrees in the third equation, and we got from the third equation that beta equals to 150 degrees minus theta. But if beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. And in order to find out the value of sinus 150 degrees minus theta, we used the second trigonometric identity that states that sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. When we substituted alpha by 150 degrees and beta by theta, so we did the calculation of this expression sinus 150 degrees according to our second trigonometric identity, and we got that the value of sinus beta equals to 5 over root 7 times 2. Okay, after we got the value of sinus beta, we implemented the law of sines in triangle DC in order to find out the value of B. According to the law of sines, in the small triangle DC, DC over sinus beta equals to DE over sinus 60 degrees. Okay, DC over sinus beta equals to DE over sinus 60 degrees according to the law of sines in triangle DC. We know the values of all the variables here, and the only missing variable is DE, that is actually B. We put the data inside this equality and we found out that the value of B equals to the root of 7 times root 3 times 4 over 5. And we have already found out the value of A. The value of A is root 7 units. So actually the area of the green triangle, that is also right triangle, equals to the base of the triangle, that is B, times the height to the base, that is A, over 2. So A times B over 2 is the area of the green triangle, green right triangle, FDE. You should remember that the height must create 90 degrees with the base B, and the height A creates 90 degrees with the base B, because angle FDE equals to 90 degrees. So A is indeed the height of the right triangle and B is the base. So A times B over 2 is the area of the green triangle, green right triangle, FDE. Okay, but we know that A equals to root of 7 units and B equals to this expression. So we substituted A by root 7 and B by the expression that we found out, and we got that the area of the green right triangle, FDE, equals to 14 times root 3 over 5 square units. Okay, or in terms of numbers, the area of the green right triangle FDE equals to 4.85 square units. Again, the area of the green right triangle FDE equals to 4.85 square units. Okay, thank you very much.